Hello to all fans of physics and physical experiments. I'm Andrei Shkednikov, and our video today will be dedicated to a device called a self-starting siphon. But first, let's recall how a regular siphon works. By the way, we have a separate video about that, where all the fine details are discussed. I certainly recommend that you watch it. Basically, a siphon is just a tube that's lowered into a container of water. And for the water to start flowing through this tube and coming out, I need to suck on the water a little bit and let the stream flow down. Don't worry that it's blue, it's just food coloring. I won't be poisoned. Now, if I raise the end of the tube a bit higher, you will see that the stream flows a little weaker. If I lower it, it flows noticeably stronger. And if I lift the end above the water level, the siphon will stop working. And now, no matter how I move the tube, it won't start again. But I want to make something that would be safe in terms of suction, even for other liquids, and would start on its own. So how should such a device be designed? And a clever, inventive mind came up with this kind of device. A regular siphon has one bend at the top, but this one has a bend at the top, then a bend at the bottom, and then another bend at the top. Well, now I'm going to lower this construction into the aquarium. And the water flowed over the edge of the aquarium and continues through the tube, filling the lower container. So how does this device work? Let's submerge the siphon in water, and for now, the water only fills its inlet bend. Let's lower the siphon further, and the water will fill the entire submerged part, gaining some speed, and then it will rise higher by inertia. If the kinetic energy of the water in the siphon isn't fully spent yet, the water will move further, filling the outlet bend. And if it can drop below the water level in the container, the siphon will start working and pumping water. Now we must answer an important theoretical question. What is the maximum height of the wall above the water level that our siphon can still pull water over? And to start figuring this out, I'll perform one curious experiment. I'll be lowering the siphon into the water so that the inlet bend is already positioned below the surface of the water level and water begins to fill it. But the outlet bend hasn't dropped to the level of the wall. Let's see what happens in this case. The inlet bend goes under the water, and then the water enters the outlet bend. And it's discharged back out. So why did this happen? To get the water to the very top of the outlet bend, some energy must be expended. And for the water in the tube, to reach the level of the water in the vessel, just as much energy is needed. And only with such energy expenditure will the siphon work. And now I'll consider an S-shaped siphon like this one. When water falls down into it, its center of gravity lowers and potential energy turns into kinetic energy. And when the water continues to rise by inertia, its kinetic energy turns back into potential energy. And if the tube is arranged symmetrically, as in this drawing, then it turns out that the water can rise to exactly the same level as it descends below the water level in the vessel. But of course, this reasoning is made for an idealized case where there are no losses. And losses can occur due to viscosity as water flows through the pipe and also at the inlet of the nozzle. And by the way, speaking of such losses, we have a video called Borda's Mouthpiece, and I recommend you watch it. Next, the idea arises to accumulate more potential energy, meaning making the lower container larger and then splashing it all into a narrow tube. And to make something like this with a funnel, additionally using the cumulative effect when the jet gushes into the funnel spout. Well, let's see how it works now. Though I have to cover the tube with my finger. Beforehand, started it. It worked, it's flowing. Still, I need to test it at a greater height. I didn't lower it as deep. Alas. Oh, it's working. Let's try raising it slightly higher. It splashed somewhere around here and didn't go any further. We haven't really improved the situation for ourselves yet. Perhaps the transition from the cone to the tube in the funnel is too abrupt and it needs to be smoother. For this, I'll use a trimmed disposable plastic glass. As for the cumulative jet, it's just excellent here. It flies up a whole meter. And by the way, speaking of cumulative jets, we have a separate video and I also recommend you watch it. With the tube attached, this device also works quite well. The jet shoots out and from the tube as well. Now I'm going to attach a curved tube to an inlet device like this. Let's see how it works. Lowering it. Down, I've got about 5 centimeters here. And it's all working now. The tube is thick and the jet is quite strong. Well, and now, let's raise it higher. And alas, the system didn't work. Let's take a look at what happened to it. We're filming at 240 frames per second, and we see that the water initially sort of caught in the tube, but then gradually receded, and the siphon, strictly speaking, just stopped. It fluctuated a bit more after that. Now let's see what happens when the siphon actually manages to work. It's clear that the water didn't fill the whole tube to the bottom right away either. Look, there's an air bubble hanging there, and only now the water begins to fill the tube completely. Now, before moving on to the final question, I want to thank everyone who supports our channel. How to do it is written below the video. I also want to say that the task called Invent It Yourself, which proposes developing various effective designs for a self-starting siphon, is currently being played at the Young Physicists Tournament. Let's see how far the young people get. But you can also come up with your own designs and write your ideas below this video for discussion. And now thank you for your attention.